Chemistry with Coach Jakes.
Charles's law helps us to understand the behavior of a gas when pressure is held constant. So the pressure stays the same, the pressure does not change. So then what happens to the volume and the temperature when that pressure is held at a constant? Okay, will my volume increase as the temperature increases? Is it opposite? What happens, right? And that's what Charles' law helps us to understand. Here at this PhET simulation, we're going to look at gases. According to Charles's law, we know that pressure is going to be held constant, and we're going to look at how volume and temperature change and impact one another when pressure is held constant. Okay, so the first thing on this one we're going to change is our temperature. The pressure you see is held constant at 12.3 according to our barometer meeting. Okay, we're going to leave the box size alone. We're not going to change the size of the box, which means in this case we're going to leave volume alone, and we're going to see how volume changes when temperature changes. Okay, so we're going to increase the temperature and decrease the temperature by heating or cooling the gas sample, and we're going to see how the box either expands or stays the same or whatnot. Here we go. Heat it up. All right, so if you notice, we was going to blow out the box, y'all. So if you notice, we went from 300 to 474 Kelvin, and the box expanded. The volume increased when the temperature increased. Okay, temperature increased, volume increased. So now let's look at what happens if we decrease the temperature. As the temperature decreases, you'll see that the volume also decreases. All right, it's saying it's too small. It throws off the pressure. We went too far with it, but that's okay. All right, now let's look at it the other way. Now we're going to play with the volume. All right, we're going to make the container either larger or smaller and see what happens to the temperature, right? So if we increase the volume, what do you think will happen to the temperature? It also increases in order to keep that pressure constant. Okay, if that pressure is to remain constant, then the temperature has to increase to incorporate the volume. Now, if we decrease the volume, you'll see the temperature drops, right? Because we know if we keep the same amount of energy, then the pressure would have to increase, but we want pressure to be constant. And so in order for that to happen, the temperature must drop. So there you have this law where we examine how volume and temperature work together when pressure is held constant. Volume goes up, temperature goes up. Volume decreases, temperature decreases. All right, those relationships are directly proportional. Okay, now if this video helped you out at all in any way, make sure you like it, subscribe, tell a friend, tell your classmates, tell your teacher. Chemistry with Coach Jakes, the place to go to get all your chemistry problems solved. See you next time. Take care. Be blessed. Peace.
Chemistry with Coach J.